Hello dear students, welcome back to chemistry online class. In the previous class I had started a new chapter, and that is a periodic table. Okay, and in that class I taught you about Dauvernier's attempt for classification of elements. What is Dauvernier's law? I explained you, and what is Dauvernier's thread? I explained you. Okay, next, why classification of elements is necessary, how many elements were known, all those things I discussed in the last class. And I gave you two examples for Dauvernier's thread. Okay, I give you first example was of fluorine, chlorine, and bromine, and second example was of potassium, rubidium, and cesium, something like that. Okay, one more example I'll give you. Example of Dauvernier's thread. Okay, this is calcium, strontium, and barium. Calcium, Ca is calcium. Okay, Sr means strontium and Ba means barium. Now, atomic mass of calcium is 40. 40 plus barium is 137. Okay, if you take the average of these two masses, then divided by 2 will give you this 177 divided by 2. It will be 8 is 16. Again, 8 is 16.5, 88.5. So this average mass of calcium and barium is very much close to the atomic mass of strontium, which is 88. Okay, atomic mass of strontium, this is 88. So Dauvergne kept strontium between calcium and barium because the average atomic masses of calcium and barium is almost or approximately equal to the atomic mass of strontium. Okay, so average mass we got 88.5 and the actual mass of strontium is 88. So these two are very much close. Okay, so this is the example. So you write one question, give an example of Dauvernier's thread and explain it properly. Okay, so example you can give any one example from, you can give this example. An example of Dauvernier's thread is calcium, strontium, and barium. Okay, after that you can explain like this, atomic mass of calcium is 40, atomic mass of barium is 137. So average masses of calcium and this barium will be, you do the calculation and find it 88.5, and this 88.5 is almost or approximately equal to the atomic mass of strontium, that is 88. Okay, so this is an example of Dauvernier's thread. Otherwise you can give the example that I gave you in the previous class, that was of fluorine, chlorine, and bromine. Okay, now write one question, that is, what are the defects of Dauvernier's thread? Why the Dauvernier's attempt for classification of elements was a failure? What was the reason behind the failure of Dauvernier's attempt for classification of elements? Okay, and your answer will be, first of all, Dauvergne could not keep or could not arrange all the known elements in a group of 3. Okay, he could not arrange or he could not keep all the elements which were known then by making group of 3. Okay, so that was the failure. And reason number 2 is the elements of same family could not be kept in a thread by using Dauvernier's law. Okay, so there are some elements which have similar physical and chemical properties. Okay, so Dauvergne could not keep these elements within a same thread. Okay, example I'll give you. Fluorine, for example, fluorine, F means fluorine. Okay, fluorine, and another is bromine, Br. Fluorine, sorry, chlorine, and Cl means chlorine. Okay, and another is bromine, Br means bromine. These 3 elements, fluorine, chlorine, and bromine, they show similar type of chemical properties, or they belong to same family. Okay, but Dauvergne could not keep these three elements within a same thread, because if you apply Dauvernier's law, these elements, okay, so the law comes as a failure. For example, atomic mass of fluorine is 19, okay, plus bromine is 80, and if you take the average of these two mass, 19 plus 80 will be 9, 8 plus 1, 99 divided by 2, so 2 4s are 8, 1 and 2, 9 is 18.5, 49.5, you got 49.5. But atomic ATOMIC, atomic mass of chlorine, Cl, chlorine is 35.5 only. See, if you while taking the average of mass of this and this, you should get the atomic mass of chlorine. Okay, but see, on taking average we got 49.5, but the actual atomic mass of chlorine is 35.5. So there is vast difference between this average mass and the actual mass of chlorine. So Dauvergne could not keep these three elements within a same group or within a same thread. So this was the failure. Okay. So two reasons are there for failure of Dauvernier's law. Okay, reason number one is he could not arrange, or he could not classify all the known elements by making specific groups or threads. Reason number one is that. Reason number two is the elements of same family could not be kept within a thread by using Dauvernier's law. For example, you can give the example of this fluorine, chlorine and bromine, like I gave you just before this one. Okay. Now another law comes. Okay, Newland's law for classification of elements. Newland's law for classification of elements. So after Dauvernier's law, Newland's law comes. Okay, Newland said that elements are arranged in increasing order of their atomic masses, and the physical and chemical properties of every eighth element, eighth means eighth or EIGHT, eighth element starting from any element is the repetition of the physical and chemical properties of the first element itself. Okay, so this is the statement of Newland's law. Newland's law says that elements are arranged in increasing order of their atomic masses, and the physical and chemical properties of every eighth element, EIGHT, eighth element, okay, starting from any element, is the repetition of the physical and chemical properties of the starting element itself. Okay, so it means this. See, there is a musical note sa, re, ga, ma, pa, dha, ni. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Sa, re, ga, ma, pa, dha, ni. After ni, sa comes. That means there is repetition. After every eighth note, repetition takes place. Okay. So same thing he did for classifying elements. So he arranged like this. He kept first hydrogen. Okay, first he kept hydrogen. After that, lithium. See. P. Okay. Co. Ni. Zinc. Property of every eighth element, starting from any element, is the repetition of the properties of the first element itself. Okay, so that was the law. Sa re ga ma pa dha ni. So hydrogen he kept first. After that, lithium. Li means lithium. Be means beryllium. B means boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, potassium, calcium. Ca is calcium. Okay, Cr means chromium, titanium, manganese. Fe means iron. Co is cobalt. Ca is calcium. Co is cobalt. Ni is nickel. Okay, Co is copper. Zn is zinc. So he arranged like this. First 1, 2, 3, 4, 5, 6, 7. He made 7 groups. Okay, and he kept the elements like this. So if you start from hydrogen, 1, 2, 3, 4, 5, 6, 7. Now 8th element will be similar to the first element, hydrogen, according to this Newland's law. The properties of every 8th element, starting from any element, is the repetition of the properties of the first element only. So if you start from this element, 1, 2, 3, 4, 5, 6, 7, 8. So beryllium. After beryllium, on 8th position of beryllium, magnesium comes. Okay, so beryllium and magnesium, they show similar type of properties according to Newland's law. Okay. And one thing he has done, cobalt and nickel he kept together. Actually they should be kept separately. Okay, like this one. But he kept cobalt and nickel together. This also has some reason that I'll explain you later. Okay. So this was the process of arrangement of elements according to Newland. Okay, Newland, he was a musician. John Newland was a musician. So he arranged the elements in a musical note system. Okay. Now question comes. You note one question. Okay, state Newland's law for classification of elements. And answer you write it, the law I dictated earlier. Okay, otherwise you can refer your book also for exact law. Okay. Next question you write it. Draw Newland's table for classification of elements and fill up first. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Draw Newland's table for classification of elements and fill up first 25 elements in the table. Okay. So with that you make question and in answer you write this one. Write sa re ga ma pa dha ni also, and then 1, 2, 3, 4, 5, 6. You make this table properly. Okay, using skill. And you have to memorize the table also. That law you should memorize. Okay, this table also you should memorize. Now the merits of Newland's law. What were the good things in Newland's law? Okay, first of all, the good things in Newland's law were, first a good thing is this law was applicable. This law worked quite well for lighter elements. Okay, till calcium, till atomic number 20, or till the element calcium, the law was very much applicable. Okay, so that was the first importance or the merits of Newland's law. Okay, number two, second was, for the first time the periodicity in the properties of elements were identified or recognized. See, there are some properties which repeats after certain interval of time in case of elements. Okay, so that property was identified for the first time by Newland. So that was the second merit of Newland's law. So it is enough if you write two merits of Newland's law. Okay, first of all, first merit is the law worked quite well for lighter elements. That is, the law worked quite well for till the element calcium. Okay, and merit number two is, for the first time the periodicity means repetition, okay, in the properties of elements were recognized or identified by Newland. So two merits for Newland's classification of elements. Okay, next is demerits. You make the question. Okay, write two merits for Newland's classification of elements, and next question you make it, write two demerits for the classification of Newland's classification of elements. Okay, so first demerit is, the law could not be applied for heavier elements. Like after calcium, the law could not be applicable. Okay, and next number two is, he kept cobalt and nickel with hydrogen, below that fluorine was there, below that chlorine was there. Group number one, with hydrogen, fluorine and chlorine, he kept two elements, cobalt and nickel. Okay, so cobalt and nickel, they are metals, and these three are non-metals. These three are gases, these two are metals, solids. So he kept these two different solids with gases. So that was the failure. Okay, this cobalt and nickel should be kept separately, but he kept with hydrogen, fluorine and chlorine. So that was the demerit in Newland's classification for the elements. Okay, and number two, group 7, he had kept iron at last. Okay, iron, this properties of iron is similar to cobalt and nickel. So iron, cobalt and nickel should be kept together because they resemble some physical and chemical properties. Okay, but this iron was kept separately. So this was the another failure of another demerit of this Newland's law for the classification of elements. Okay, if you write two demerits, then that will be sufficient. So first question I said, state Newland's law for the classification of elements, and answer also I explained you. Okay, number two, next I said next question was draw Newland's table for classification of elements and fill first 25 elements. That also I explained you. And third is, what were the merits in Newland's classification of elements? So I gave you two merits. Okay, first merit was the law worked quite well for the lighter elements. That means still calcium, the law was very much applicable. Okay, and next was for the first time periodicity in the properties of elements were identified. So that was the second merit. Demerits ma ke bhane bhandakeri, I said that the position of cobalt and nickel. Okay, cobalt and nickel was kept along with hydrogen, fluorine and chlorine. So in spite of having dissimilar properties, they were kept in the same group. Cobalt and nickel were kept with hydrogen and those. Okay, hydrogen, chlorine and fluorine, they are non-metals, but cobalt and nickel, they are metals. So they cannot be kept within the same group. So that was the failure. Okay, next, iron resembles cobalt and nickel, but it was kept separately. That was another failure. Okay, now after Newland, Mendeleev came. Dimitri. Dmitry Mendeleev, M-E-N-D-E-V-S, Mendeleev, Dmitry Mendeleev. I'm not sure about the spelling, okay? You check the spelling in your book. So Dmitry Mendeleev came with a new idea for classification of elements.